we are going to start the third section of Chapter 5, which is going to be division of polynomials. If you recall, in 5.2, we only added, subtracted, and multiplied, and we didn't divide because, one, dividing just requires a little bit more work, but also division is just kind of a very important part of what we're going to do today and moving forward in Chapter 5. So it kind of just gets its own section due to importance. Okay, you have two learning targets, and the first is that you're just going to be able to take two polynomials and divide them. Okay, and then the second is that you're going to be able to determine if a polynomial is a factor of another polynomial by using division. And obviously, we'll talk about that when we get there. Okay, the first way, we're going to have two different methods of dividing, and the first is going to be long division. In general, long division is the more complicated of the two, and furthermore, that it is the reason why we teach it to you, though, even though it's more complicated and the other way is significantly easier, the reason why we use it is because it's guaranteed to work. We'll have a second type of division called synthetic division. And although synthetic division is great, it's super useful, it's super quick and easy, we have to have long division because we can't use synthetic division in every scenario. Okay, so let's go ahead and start this. Basically, I want to take x to the third power, or x cubed, and I want to subtract 2x minus 2, or subtract x squared minus 2x, and then add 8. And I want to take this polynomial and I want to divide it by x minus 1. Meaning I'm looking for the expression that I would have to multiply by x minus 1 to get this result. Okay, so what you're going to take is you're going to take what you're dividing by and you're going to put it outside. It's going to be set up exactly like a long division problem when you're using just traditional numbers and you're doing that standard logarithm. Okay, and then what I'm going to do is I'm going to go ahead and put the long division bar, and I'm going to take what I am dividing inside here. Okay, so what I'm going to do here now is I'm only going to look first term to first term. Okay, because the minus 1, I'm never really going to be able to get at multiple things to match up on a consistent basis. So what I want to do is I want to figure out, what do I have to multiply this first term here to become this first term here? So what do I have to multiply x by to get x to the third power? Okay, so you need to think about like, well, like a typical answer would be 3. But if I multiplied x by 3, I would get 3x, and that's not what I have here. I have x to the third power. So we think if I go x times x, I'll get x to the second power. But again, I need another x in there to get me to the third power. So what I need to multiply x by to get x to the third is x squared. Okay, so I know I need to multiply by x squared because if I take x squared times x, I'm going to get x to the third. And so what I'm going to do is I'm going to take this x squared and I'm going to multiply it by x to get x to the third power, and that's what's going to go here. I'll just go ahead and do this in red. So what I'm doing in red is when I'm multiplying. So I'm going to x squared times x, get x to the third. And then I also have to take x squared and I have to multiply it by the other part of this binomial. Okay, so I'm going to go x squared times negative 1 is negative x squared. Okay, and then what I do is I take that result and I subtract, just kind of like you would in regular long division. Okay, so now here I have x cubed minus x cubed. Well, we know those cancel out to 0. Okay, and then I have negative x squared, and I'm taking away negative x squared. So taking away a negative is adding. Negative x squared and positive x squared, again, those cancel each other out. Okay, technically there's zeros here, so I can just bring these values straight down. Okay, and one thing I would point out is do not expect the first two terms to cancel out like this every time. Actually, in general, they don't cancel out like that every time. Okay, looks like my screen is attempting to focus. Okay. I'm going to do the exact same thing. I am going to go ahead and go x. I want to figure out what do I have to multiply this term by to become the exact same as this term. So what do I have to multiply this term by to become this term? Well, x, I don't have to raise the exponent, so I'm just looking for a number. So I have to multiply x by -2 to become -2x. I'm going to put a little -2 here. Okay, and then I have -2 times x is going to be -2x. And that's good that we got the same thing here, because when we're subtracting the same thing, they're going to cancel out to 0. Then I'm going to go -2 times -1, which is +2. Okay, and so then I can go ahead and I can subtract again. So -2x take away -2 is x is 0. So again, those cancel. And then 8 minus 2 is 6. Okay. So then as I look at this, I'm going to go ahead and say, well, what do I have to multiply x by to become 6? Well, the answer to that's a little more complicated, because it would have to be like 6 over x. And that's a little more complicated than what we really want to deal with. Okay. So when this number is what I would call a remainder, if you remember that, okay, is a remainder. If you remember that from, well, gosh, whenever you learned long division, quite some time ago, I would imagine. And then that's essentially like getting a decimal, right? Like if you divide 4 by 7, for example, so if I were to divide 4 divided by 7, I would say, well, 4 goes into 7 one time, and so then I would get this. Okay, and so then I would say, hey, there's a remainder of 3. So it'd be like, at some point you would say remainder 3. Or you could keep going and say, well, how many times does 4 go into 30? And so 4 goes into 30, 24, 28, so 7 times. So then you would go ahead and get 1.7, and that would give me 28. And then you would add a 0 and say, hey, 4 goes into 25 times, so my answer is 1.75. Essentially what that means is that 4 doesn't divide into 7 evenly because I got a remainder of 3. It's the same idea. X minus 1 doesn't divide into this polynomial evenly, so I get a remainder. It's essentially equivalent to me getting a decimal. Okay, so what my final answer here is x squared minus 2 plus, and you take that remainder and you put it over what you're dividing by, and this is my answer. Okay. And again, this part here is basically like the decimal equivalency. Okay, so what I want to show you now is that if I truly multiply this times this, I will get my original answer. Okay, and just making sure everything's good here. So I can go ahead and do this by saying I'm going to take x minus 1, and I'm going to multiply it by the 3 parts of that trinomial I got. X squared minus 2, and then plus 6 over x minus 1. I'm going to show you that these actually do multiply by each other to get my answer that I got originally. Okay, so just standard box multiplication that we've done for quite some time. So x times x squared is x to the 3rd. Okay, and then I'm going to go x times -2, which is -2x. We're going to go x times 6 over x minus 1. Well, that's just 6x over x minus 1. Okay, and then I'm going to go x squared times -1 is -x squared. Then I'm going to go -1 times -2, which is +2. And then I'm going to go -1 times 6 over x minus 1. That's just -6 over x minus 1. Okay, and so now we would just kind of add all these up. I'm going to notice that, typically we'll see that our diagonals are like terms, but they are not like terms for us. Okay, so I have to leave them separate. So I'm going to get x cubed minus x squared minus 2x plus 2 plus 6x over x minus 1 plus -6 over x minus 1. Okay, and it seems pretty complicated. That's 6x over x minus 1 and plus. Well, you know, these are like fractions, hence the decimals. Okay, and so what we can do is they have like terms. Okay, they have like terms of over x minus 1. They have common denominators, so I can actually just condense them together. Okay, so then this is going to be plus 6x minus 6 over x minus 1. Okay, and we'll deal with this in, I believe it's chapter 7, possibly chapter 6 more. But, you know, one thing I'm noticing about this here is that they have a common factor of 6. So what happens if I take that common factor of 6 out? Okay, I can just say, hey, this is 6 times x minus 1, all divided by x minus 1. Well, what happens here? Something special, right? We have a factor of x minus 1 on the top that I'm multiplying by and a factor of x minus 1 on the bottom that I'm dividing by. Those actually cancel each other out. And so what I end up with is x cubed minus x squared minus 2x plus 2, then plus 6, because these cancel each other out. All that's left over is 6. This means it simplifies into x cubed minus x squared minus 2x plus 8, x cubed minus 2x squared minus 2x plus 8. Okay, that was just a little extra stuff for you to deal with, just to see that it truly, division means we're dividing, we're figuring out the value that you have to multiply by this to get the original. Well, we figured it out and showed that if I multiply this times x minus 1, I will get x cubed minus 2x squared minus 2x plus 8. Okay, and so, yeah, that's basically it. Although what I just showed you will not be required of you to do. I just wanted you to see that visual. Okay, let's do number 2. Okay, number 2, we have a little higher degree, and we're multiplying by a trinomial. Okay, so we have a 4-term expression divided by a 3-term expression, and the process is the same. Okay, so I'm going to go x squared plus 3x plus 2, and I'm going to divide it into 2x to the 4th plus 3x squared. One thing you should do, 3x cubed, is we're missing the x squared term. If you notice, we want x to the 4th, x to the 3rd, and then we went straight to x to the 1st power. I would go ahead and just get in a habit of, if you're missing a term, that means that it's being multiplied by 0. So just go ahead and add that in, right? It's the missing part, because we normally would not write that. Okay, so plus 5x minus 1. Okay, process is the same. What do I have to multiply this by to get to this? Well, there's a sneaky 1 here, so 1 times 2 would get me to that 2. And then x squared times what would give me x to the 4th times another x squared. So now I have to multiply each of these terms by x squared, or 2x squared. Okay, so x squared times 2x squared is 2x to the 4th. 3x times 2x squared is 6x to the 3rd. And then 2x squared times 2 is 4x squared. Okay, and that's why I write the 0x squared is when it's missing in its slot, is it actually just helps us align the problem. It's not that it's wrong if I don't write this, but it's often helpful. Actually, let's put a little note right above this so we know. Always include I'm just going to call it missing term. Okay, and the term we were missing the x squared term, so we're going to include it here. Okay, and so then now that I have this, I can subtract. So these again are going to cancel. Okay, and 2x to the 4th minus 2x to the 4th is just 0, canceling out. 3x cubed minus 6x cubed, I'm going to get negative 3x cubed. Okay, 0x squared, take away 4x squared, I'm going to get negative 4x squared. 5x take away 0, well, that's just 5x. Negative 1 take away 0 minus 1. Again, I'm just dropping these suckers down. Okay, and now I can just repeat my process. What do I have to multiply x squared by to become negative 3x cubed? Well, I'm going to have to multiply by negative 3. And I'm also going to have to multiply it by x. Okay, so negative 3x times x squared is negative 3x cubed. Okay, so I'm going to get negative 3x cubed. Negative 3x times 3x is minus 9x squared. Negative 3x times 2 is negative 6x. Okay, and it's problems. These problems you have to be very careful when you're subtracting negatives. You just have to kind of know that it's addition and just know how to maybe use a calculator if necessary. So negative 3x cubed take away negative 3x cubed. Well, that's going to cancel. Negative 4x squared take away negative 9x. That's the same as negative 4 minus negative 9, which is the same as negative 4 plus 9. And that would give me a positive 5x squared. Okay, same thing. I'm minusing a negative. So 5x take away negative 6x is positive 11x. And then I would just bring this down. There's nothing to combine it with. Okay, and then lastly, I have to see what do I have to do to multiply x squared by to become 5x squared. I would just have to multiply it by 5. Okay, and so then I'm going to go ahead and go 5 times x squared is 5x squared. 5 times 3x is 15x. And 5 times 2 is 10. Okay, these again would cancel. And then I'm going to go 11x minus 15x is negative 4x. And negative 1 minus 10 is negative 11. Okay, my degree here is 1 and my degree here is 2. So this is a lesser degree. So I'm not going to be able to easily multiply this by anything that's going to get me to negative 4x. So again, this is my remainder. Okay, leaving with my final answer being 2x squared minus 3x plus 5. And then plus my remainder over what I'm dividing by. And this here is my answer. Okay, and I could do what I did in the previous problem and show you that I can multiply this times this to get my result. I don't see it being necessary, as we've kind of already shown that to be the case. Okay, so always include this example 2 really is no different than the previous one. It's one to show you that I can divide even by a trinomial. And also that if I'm missing a term, I want you to try to include it. Okay, so I want you to try A and B on your own and go ahead and check it with me when you are done. And you can go ahead and check it right now. So I'm assuming that you've already done this and you're just trying to see what the answer is. Okay, so I'm going to go ahead and put x squared minus x plus 1. And I'm going to divide that by x to the 4th. And I'm missing the x to the 3rd power term, so I'm going to include that. Okay. And so then I can go ahead and start. What do I have to multiply x squared by to become x to the 4th? Well, I have to multiply by x squared. X squared times x squared is x to the 4th. X squared times negative x is negative x to the 3rd. X squared times 1 is x squared. And I subtract. Okay, so I can go ahead and cancel these out. 0x cubed take away negative 1x cubed is a positive x cubed. 2x squared take away x squared is 1x squared. And then these have nothing to combine with. I'm just going to drop them down. Okay, same thing. What do I have to multiply x squared by to become x to the 3rd? I'm going to have to multiply by x. Okay, so x squared times x is x cubed. X squared, or x times negative x is a negative x squared. I probably shouldn't have put that plus sign, but plus and negative is all the same. Okay, and then x times 1 is x. Okay, these cancel because they're the same. x squared take away negative x squared. That's 2x squared. Okay, negative x take away x. It's negative 2x. And then I can drop my 5. Okay, and then lastly, I can go x squared times 2 is going to get me to that. So this is going to be 2. Okay, so 2 times x squared is 2x squared. 2 times negative x is negative 2x. 2 times 1 is 2. And then I can subtract. These cancel. These also cancel. And so I'm just left with 3. That's my remainder. Okay, and I'm going to get x squared plus x plus 2 plus 3 over x squared minus x plus 1. And that's my result. Okay. All right, letter B. Okay, letter B is, we're looking at this here, and I am missing a term. I'm missing the constant term, but that's all right. I can deal with that here in a moment. So I'm going to get x minus 2, and I'm going to divide it into negative x cubed plus 3x squared plus x, and then plus, and I'm missing that constant term, so I'm going to put a 0. Okay, what do I have to multiply x by to become negative x cubed is negative x squared. And then negative x squared minus 2 is plus 2x squared. I'm going to subtract. Okay, and these values here are going to cancel. 3x squared minus 2x squared is x squared. And nothing to do with these, so I'm going to bring them down. Okay, so what do I have to multiply x to become x squared? Well, I have to multiply by x. So x times x is x squared. X times negative 2 is negative 2x. Then I can subtract. These are going to cancel. All right, x times negative x minus negative 2x is 3x. And then again, plus 0, I just drop that bad boy down. And then what do I have to multiply x by to become 3x? I have to multiply it by 3. Okay, 3 times x is 3x. 3 times negative 2 is negative 6. And I subtract. 3x minus 3x cancels. 0 minus negative 6 is positive 6. That's my remainder. Okay, and my final answer is negative x squared plus x plus 3 plus 6 over x minus 2. And that is indeed my answer. Now, I went a little bit quick. That's because the instruction, I took my time. Here, we're just checking our work, and now you can see it. You know, you can always go back if you feel like you need to see it again. Okay, now let's talk about synthetic division. Synthetic division, in my opinion, is significantly easier than long division. Okay, but it only works when you're multiplying by it like a binomial, specifically with like the value in front being 1. Okay, and so it's kind of like upside down division. Okay, so let's go ahead and do this. Okay, you also want to include missing terms, just like the previous one. Okay. So what I want to do is I want to put the value that makes this equal to 0. Okay, you write your bar upside down, and you want to put the value that makes this 0 out here. Okay, it looks like I'm frozen here. There we go. All right, so which for me is 3. The other way a lot of people look at it is they just take the opposite of what this value is. Okay, then you're going to want to put the coefficients of each value here. Okay, and so this would be negative 1 and then 4. Okay, we're missing the x term, so that would be a 0x and then 9. Okay, you can go ahead and start by dropping this thing down here to negative 1. Okay, and then what you're going to do is you're going to go 3 times negative 1 is negative 3, and then you just add. Okay, so this is going to get me here. and then you just add 4 plus negative 3 is 1. So 3 times 1 is 3, and you're going to put that there. 0 plus 3 is 3. 3 times 3 is 9. 9 and 9 is 18. Okay, and that's basically my answer. Okay, so it's going to be remainder constant x squared. So my answer is negative x squared plus x plus 3 plus 18 over x minus 3. Okay, that is it. Okay, so it does work a lot better than long division. So whenever you have a binomial with the value specifically of 1 there, it makes it the easiest, okay, is you want to use synthetic division, and you should actively use synthetic division. It's just when we have problems like A, for example, we cannot use synthetic division because it's trinomial. Okay, so that's why we have to kind of have 1. Okay, so if we look at this here, we can go ahead and kind of do the same thing. Okay, so we're going to think about what number is going to make this 0. Well, that is negative 1. And we can go ahead 3, negative 2, 2, 3, 2, 1 constant, and then negative 5. This one has no missing values, so we can just write them down as is. We're going to drop our 3. So negative 1 times 3 is negative 3. Okay, negative 3 times, or negative 2 plus negative 3 is negative 5. Negative 1 times negative 5 is positive 5. 5 and 2 is 7. Negative 1 and 7 is negative 7. Negative 5 and negative 7 is negative 12. My remainder, my constant, my x squared. Okay, so this is going to be 3x squared minus 5x plus 7 plus negative 12 over x plus 1. Okay. And again, I can go ahead and show us. I'll use the first example that these multiply together. Okay, so if I go box method here, I can show us that this works. Okay, negative x 3, 18 over x minus 3, and then x minus 3. Okay, so I can go ahead and show you that if I multiply these together, I get my answer. So x times negative x is negative x cubed. X times x is x squared. X times 3 is 3x. X times 18 over x minus 3 is 18x over x minus 3. Negative 3 times x squared is positive 3x squared. Negative 3 times x is negative 3x. Negative 3 times 3 is negative 9. Negative 3 times 18. Negative 3 times 18. I don't know what that is off the top of my head. 3 times 16, 24. 3 and 1 plus 54. So this is negative 54 over x minus 3. Okay, and so then I can go ahead and add these parts together. This is 4x squared. This is 0x. And then minus 9. And then here, plus 18 over x minus 3 plus negative 54 over x minus 3. Okay, these can combine together because they both have a common denominator. I'm not going to include that because it's 0. All right, I notice that this has a common factor there at both divisible by 18. So I'm going to divide an 18 out. Over x minus 3 times x minus 3. Okay, so I divide 18 by this, and 18x divided by 18 is x. Negative 54 divided by 18 is negative 3. These will cancel, and I get negative x cubed plus 4x squared minus 9 plus 18. Okay, which works out perfectly. X cubed, okay, plus 4x squared, and then that's positive 9. Okay, and x cubed plus 4x plus 9. So as you can see, it does indeed work. Okay. Now, let's just talk about what is or is not a factor very quickly. Okay, so as this is my remainder here, right? And this is my remainder. Okay, essentially, if I have a remainder, just like at the beginning, I divided 7 by 4, and I got to a remainder, that means that 4 doesn't divide into 7 evenly. As opposed to if I were to divide 4 into 8, it would go in there exactly twice. It goes in there nice and neat 2 exact times. Okay, that means 4 is a factor of 8. But 4 is not a factor of 7 because there's a remainder when you divide. Okay, so as I can look at this, x minus 3 is not a factor of this expression because I got a remainder. This, x plus 1, is not a factor of this because it doesn't divide evenly into it. I get a remainder. As you can see here, these are wonky, clunky remainders. Okay, so there is a polynomial remainder theorem. If a polynomial f of x is divided by another polynomial, x minus a, then the remainder is f of a, meaning whatever this a value is, okay, the remainder will be whatever you plug into here, okay? So if and only if f of a is 0, then the polynomial is a factor, meaning if I take the value that makes this 0 and I plug it into here, okay, that means that if this is 0, then that means this is a factor of this, meaning it divides into it evenly. Okay, so let me grab my calculator and we can see that together. All right, and then I'm going to go ahead and show you 2 ways to do this. Okay, so, and I'll show you one way with 4 and one way with 5. Okay, so what is the x value that makes this 0? It would be x is 7. Okay, so, and you can see if the a value here was 7, it would plug it in and it would be that. Okay, so if x is 7, okay, makes this 0, that means that x minus 7 is a factor if and only if I take 7 and plug it into all the x values and the result is 0. So let's go ahead and see that. Okay, so if I take 10 times 7 cubed minus 89 times 7 squared plus 139 times 7, and then subtract 42. If I take that, if it's 0, I will have, that means it is a factor. Okay, so we can do this all in the calculator. Okay. All right, so I'm going to take 10 times 7, and I'm going to take that to the 3rd power. Okay. Then I'm going to subtract 89, and I'm going to multiply it by, not x, 7 squared plus 139 times 7, and then subtract 42. So I'm taking what I have written here, and I know it's a little blurry, but that's because the calculator's taking all the focus. If I take that, my result is 0. Okay, when I take all of that, it's 0. What does that mean? That means my remainder is 0. Since my remainder is 0, x minus 7 is a factor. Okay, so you can go ahead and take the value that would plug this in, okay, and you can see that if the result is 0, it's going to be a factor. Let's actually show that exact same thing using long division. Okay, so the value that would make this 0 is 7. Okay, and we're going to use some long division here, or synthetic division. Okay, and we're just going to go ahead and see that we're going to get a remainder of 0. Okay, so I can drop my 10. So 10 times 7 is 70, and then I would get negative 19 here. Double head and check that quick. Big numbers, I always am extra careful. Okay, and then, okay, so 10 times 7 is there, and then I'm going to go negative 19 times 7, so negative 19 times 7 here is negative 133. And here I get a value of 6 left over, 139 plus negative 133. Okay, and then I'm going to go 7 times 6, so 7 times 6 is 42. 42 and is 0. Okay, so what does this mean? Again, this is my remainder. Okay, so when you take and divide two polynomials by each other, if the remainder is 0, that means it's a factor. That means it divides into it perfectly. Just like 4 divides into 8 exactly 2 times, no remainder left over, that means 4 is a factor of 8. This here means that x minus 7 divides into 10x cubed minus 89x plus 139x minus 42, and it divides into it evenly. Constant x squared. It divides into 10x squared minus 19x plus 6. Okay, and so as you can see, it divides into it evenly, a nice neat polynomial. As opposed to like these ones up here, I got that remainder, so it just means it just doesn't divide into it nice and neat. There's some sort of like decimal left over. Okay, so when you're doing problems like this, the important part is that you're able to determine whether one polynomial is a factor of the other or not. Okay, I don't care what method you choose. So here, if you went ahead and said, I like just plugging in 7 and seeing if it's 0. If you like that, that's fine, as long as you can determine what the factor is. If you want to do synthetic division, okay, and find out that the remainder is 0 and determine that it is or is not a factor, that's also fine. Okay, so number 5, again, we just want to determine whether this is a factor or not. Okay, so the value that's going to make this equal to 0 is 1. So I'm going to go ahead and plug it in. So I'm going to go ahead and get 1 squared minus, or 1 cubed minus 1 squared minus 2 times 1 plus 8. All right, 1 and 1, that should be 1. It's red. And then I can just go ahead and type this whole thing in. Okay, so I'm going to get 1 cubed minus 1 squared minus 2 times 1 plus 8. And here I get 6, a remainder of 6. Okay, so what does that mean? That means x minus 1 is not a factor. Okay, and again, I'm going to show that with long division. So we're going to go ahead and put a 1 out here, because that's the value that will make this 0. And we're going to get 1, negative 1, negative 2, and 8. 1 times 1 is 1. This is 0. 1 times 0 is 0. This is negative 2. 1 times negative 2 is negative 2. 8 and negative 2 is 6. Okay, so we have a remainder, a constant, an x term, and an x squared term. This means here, remainder 6, that means it's not a factor. It doesn't divide into it evenly. It does divide into it, just not evenly or fits in there perfectly, like 4 and 8, or 4 and 12, or 3 and 12. Okay, so I don't really care what method you use. Let's go ahead and just have you use one of each of these. Let's go ahead and use the polynomial remainder theorem for this one, and then have you use polynomial remainder theorem for D, but then go ahead and use synthetic division to determine E. Okay, so I want you to use one of each. Okay, so we're using the polynomial remainder theorem for this one. So my x value is going to be equal to 2. So my x value is 2, so I can go ahead and type this in. I'm going to get the opposite of 2 cubed plus 3 times 2 squared plus just 2. And we want to see what that result is. All right, let's see if I can shift it up just a bit so it's a little clearer. So I'm going to get the opposite of 2, cubed plus 3 times 2 squared, 3 times 2 squared, and then plus 2. And that remainder is also 6. So we get 6. That is not 0. My remainder is 6. I have a non-zero remainder, so that means x minus 2 is not a factor. Does not divide evenly. It does not divide evenly into this polynomial. Okay, that was D. Okay, using the polynomial remainder theorem. Okay, I want you to use synthetic division to determine whether this one is a factor or not. Okay, so the value that makes this 0 is negative 2. Okay, and then we're going to go ahead and plug these values in. 2, 1, negative 11, and negative 10. We can just go ahead and write the coefficients here because there's no missing term, so I don't need a 0 or anything like that. Okay, I'm going to drop my 2. Negative 2 times 2 is negative 4. 1 plus negative 4 is negative 3. Negative 2 times negative 3 is 6. And this here is negative 5. Negative 2 times negative 5 is 10. 10 and negative 10 is 0. This is my remainder. Okay, so this factors into my constant, my x squared term. So this factors into 2x squared minus 3x minus 5. Okay, meaning that x plus 2 is a factor. Okay, it is a factor because my remainder is 0, meaning that if I take x plus 2 just times this, I'm going to get this. There's no extra remainder nonsense like we got at the top. Okay, so that's a very big thing. I mean, if I could pick two things here, in general, we're going to need to know synthetic division more than long division, although long division may be or is going to be necessary in some aspects. Okay, you need to know that if the remainder is 0, that means that the polynomial you divided by is a factor of the other one. Okay. Otherwise, that's it for Chapter 5, Lesson 3, and you can move on to the homework, and I will see you for the next video, 5.4.